All right, so the first couple lessons of Unit 2 are going to be looking at something called a transformation. So you may remember a couple things from geometry in terms of like reflections and translations and rotations. Those are examples of transformations. So what we're going to be doing here is looking at them in terms of some of the functions that we will be working with this year. Okay, so we're going to start off by just talking about some of the basic vocabulary and a couple of the translations, and then we'll add on to that next class. All right, so I gave you just kind of 8 examples of what's called a parent function. And a parent function is the most basic function in the family. Okay, so functions that belong to the same family share key characteristics. So for example, if we look down here at this quadratic function, this is in the shape of a parabola. Okay, so any parabola is going to be part of the quadratic family. But this is the most basic form because it's just y equals x squared. Nothing is being added to it, nothing is being multiplied to it, or anything like that. Okay, the big 4 functions that we will be looking at are going to be the constant function, the linear function, quadratic, and absolute value. Okay, we will be looking, or in terms of this, what's coming up this unit. In the next unit, we will look at cubic functions, and then second semester, we'll take a look at the other 3. So we're just going to kind of focus on these main 4 right now. Okay. So an example of a constant function is just going to be any horizontal line. So if you remember from last unit, anything that has a horizontal line just passes through the y-axis, so it should only have a y in it. And in this case, our y-intercept is 1. So this would be y equals 1. Okay. When we talk about the domain and range of a parent function, we are talking about what can x be. Okay. So let's look at this next function for the linear. Okay, a linear function, the most basic one is just y equals x. So the slope is 1, the y-intercept is 1. So we can think of that as 1x plus 0. Okay. So again, for the domain of your function, those are what we call the allowable inputs. What are we allowed to plug in for x? Okay, and that'll make a little bit more sense when we get to things where certain values aren't allowed. Okay, so if I look at my line, a line goes forever and ever in both directions. So all values of x as I go to the right are going to be there, and all values as I go to the left are going to be there. So the domain is what we call the set of all real numbers. There is nothing that's not allowed to be plugged in for x. And for a straight line, for the range are the corresponding y values. So based on what x is allowed to be, what can y be? So if we look at this function, this line goes down forever and up forever. So every value of y that exists will be part of this line. So the domain and range of a linear function will always be all real numbers because lines extend infinitely in every direction, up and to the right, down and to the left, or vice versa. Okay. The next parent function that we're going to look at is the quadratic function. Okay. So the most basic quadratic function is going to be y equals x squared. Okay, so you know that it'll be quadratic because the highest exponent will be a 2. So a quadratic function will always be a parabola. So it'll be what we call U-shaped, look like a U. So when we look at the domain, That's what are we allowed to plug in for x? Well, any value can be squared, whether it's negative, whether it's positive, a decimal, a fraction, every single type of number can be squared. So there's nothing that's not allowed to be plugged in for x here. So the domain is once again all real numbers. Okay? But when we look at our y values here, nothing below this is part of my function. Nothing below the x-axis. All of my y values are from this point up. So with our parent function, that means that the range of this function will be y values that are greater than or equal to 0. So again, the smallest, the lowest point, this part of your parabola, if you remember, is called the vertex. So the range of a parabola, of a quadratic function, will always be where your vertex is, and then up or down if your parabola is flipped, which we will look at later on in this lesson. Okay. So the next couple, well, I guess let's do absolute value first, and then we'll do the ones that I just kind of want to take a quick little look at. We're not going to talk in a lot of detail until we get to that specific unit. So the absolute value function, if you remember absolute value, that's how far away from 0 your value is. So if you're looking for the absolute value of, let's say, -5, what that question is really asking you is how far away from 0 is -5. So the absolute value of -5 is 5 because you're 5 units away. Okay? And so this will always be V-shaped. So kind of 2 lines that connect there. Okay? So if we again think about the domain is what are we allowed to plug in? Well, you can take the absolute value of any number because any number will be some distance away from 0. So once again, our domain is all real numbers. But if we look at our graph again, it looks like this. So my smallest y value, this isn't really called the vertex because that's specific to a parabola, but you can kind of think of it that way. This bottom point right here, nothing is below that bottom point. So the y values of this function start at this point and are only above that. Okay, so my range would be y values that are greater than or equal to 0. Okay, so those are kind of the big 4 that we're going to be looking at and analyzing when we're talking about the transformations. Okay, so you're responsible for being able to figure out the domain and range, which we will obviously practice as we move through the next couple lessons. But I do just want to talk about a cubic function. Okay, so for anything that's cubic, your highest exponent will be a 3. Okay, and it takes on this shape, so kind of looks like a chair. Like if you picture yourself sitting on that chair, you're hanging off the end of it, you're sitting. You guys know by now that I am probably the worst artist in the world. My 2.5-year-old has better art skills than I do. So that's you sitting in the chair. If you can even call that art, I don't know. That's a stretch. The square root function is going to look like this. So y equals the square root of x. We'll kind of start here and kind of be that half sideways parabola. And these can all be graphed. So what these mean is, like, if my x value is 2, the square root of 2 will be this y value right here. The square root of 4 is 2. So that's how that graph is created. We'll spend a lot of time at the beginning of second semester talking about exponential functions. For an exponential function, our variable is the exponent, hence exponential. We're not going to worry about the domain and range here. And then the inverse function is 1 over x. So in math, when you think about when we, well, no, never mind, we haven't gotten there yet. But the inverse function means that we're reversing it. So for our linear function, we had y equals x. This is really x over 1. So the inverse function is going to be the inverse of that. so x would be in the denominator. Okay? All right, so now let's look at some of the specific transformations with these parent functions. Okay? So let's just first identify the function family to which the graph belongs. And then we're just going to do some comparisons before we really get into how we discover or determine the specific type of transformation. Okay, so when I look at this, I see that it's V-shaped. So that means that this is part of the absolute value family. Okay, so what I want you to do is look at how this graph looks in terms of its location and its shape compared to our parent function here, and just jot down a couple differences that you notice. Or just think about it. Okay, so when I look at the difference between my parent function and this one, my parent function, this bottom point right here, is at 0, 0. The bottom point here is at 0, 1, so it looks like this was shifted up 1 unit. Okay. It also looks a little bit narrower than this one. So let's just kind of look at what has changed from the equation of the parent function, and we'll start piecing some of those things together. Okay, the equation of my parent function is y equals the absolute value of x. This is 2 times the absolute value of x plus 1. Okay, well, this is shifted up 1, so maybe this has something to do with this. And maybe multiplying by 2 has something to do with the more narrow. Let's see if that continues as we move through some of these other examples. So here I see a straight line. So this is part of our linear family. Okay, and I know this is kind of hard to see. This is h of x equals -3 times the quantity x minus 2. It's hard for me to even see. That's what this equation is. So if we look again, let's compare it to our parent function in terms of both the equation and the look. So here it looks like this passes through the origin, 0, 0. That's where my y-intercept is. But here, my y-intercept is 6. So that means that we were shifted up 6. And what else is different? The direction is different. This goes up and to the right. This goes down. And the line looks a lot steeper. Okay, so let's distribute this through and just kind of, again, we'll piece some things together. So when I distribute that -3, I get -3x plus 6. So when I compare this equation to the equation of the parent function, okay, what's changed? Well, the slope here was +1. The slope here was -3. If you remember what we talked about in terms of slope in Unit 1, the negative flips your line. Then this number right here is bigger than 1, so it's going to be steeper. This represents our y-intercept, so if our y-intercept was 0, this is shifted up 6 units. Okay? So those are some of the transformations we are going to talk about. Shifting, reflecting, and then we'll talk about stretches and shrinks next class. Okay, so here's some of the key vocab. A transformation changes the size, shape, position, or orientation of the graph. A translation, so this is different. I know the words sound the same, but they're different. Transformation is a very generic term. Translation is a specific type of transformation. Okay. That is a graph that shifts a graph horizontally and or vertically, but does not change the shape, the size, or the orientation. A reflection is a transformation that flips a graph over a line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point, but on the opposite side. Okay. All right, so let's look at these two, or I guess three. 1, 2, 3 examples, and then we'll draw our conclusions from there. Okay. Now I'm going to be showing you some tricks on the calculator, so please make sure that you are following the keystrokes so that you know what to do. And if you're using the TestNav app, make sure you're practicing that too. Now, these things do not have to be done on a graphing calculator. It's just a lot more efficient to do. All right, so this says to graph g of x equals x minus 4 and its parent function. Okay, so let's graph the parent function first. Based on what I have, we should know that this is a linear function because the highest exponent is 1. Okay, so here is my parent function. I'm going to put my x and y values in this column, and then here is my transformation. Okay, so let's just pick some values for x. I'm just going to go from -2 to +2. So -1, or -2, -1, 0, 1, and 2. If you don't have a graphing calculator, then what you do is you just plug these x values into your equation, and that'll give you your output, which for this one isn't bad to do. So if y is equal to x, that means these values will also be -2, -1, 0, 1, and 2. So when I graph it, -2, -2 will be down here, -2, -1, and you could have graphed it, again, plotting this, the y-intercept and the slope, just like we spent all of Unit 1 doing. Okay, so here's my parent function, the most basic form. The slope is 1, the y-intercept is 0. Okay, now let's look at my transformation. So based on what we did up here, my slope is not changing. Okay, so I would expect this line to be going in the same direction and have the same steepness. What's changing is my y-intercept. So if we look at what happened up here, we added 1 outside here, and our graph was shifted up 1. We added 6 to our parent function here, and our graph was shifted up 6. So if I'm subtracting 4, think about what that would mean. Okay, so make a prediction in your head and let's see what we come up with. So if I wanted to fill in the table for this, and again, this is a linear function, so you guys know how to graph these, but I just want you to practice filling in a table of values. So when we get to some of the harder ones, you guys know what you're doing. So for this transformation, if you don't have a graphing calculator to do what I'm going to show you here in a second, we would take the same x values and substitute them in. So if x is -2, -2 minus 4 is -6. Okay. -1 minus 4 is -5. 0 minus 4 is -4. 1 minus 4 is -3. 2 minus 4 is -2. Okay. So then we'll graph these ordered pairs. -2, -6, -1, -5, 0, -4, 1, -3, and 2, -2. So think about the predictions, again, that you guys made. The steepness is the exact same, the direction is the same, but my y-intercept in all of these points were shifted down 1, 2, 3, 4. So we would describe this as a translation four units down, or shifting 4 units down. Okay. So let's look at another one, and we're going to use our graphing calculators to fill in the tables for this next one. So this says graph h of x equals x minus 2 quantity squared and its parent function. Okay, then describe the transformation. So we need to be able to recognize, all right, I see an exponent of 2, so that means that this is part of the quadratic family. Okay. So let's graph these same 5 points. So from negative 2 to 2. So when we graph the parent function, again, here's the most basic. Nothing's being added, subtracted, multiplied, divide. So when we plot these points, if x is negative 2 squared is going to be positive 4. Negative 1 squared is going to be 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So when I plot those, negative 2, 4 would be right here. Negative 1, 1 would be here. 0, 0. 1, 1. 2, 4. Okay. We know that this is a parabola, so we have to be careful when we sketch it. It should be the U shape, not the V shape. So make sure you curve the bottom of it. And I'm actually going to go 1 farther just to make this accurate. So 9 and 9. So negative 3, 9, just so I can connect. We always want our graph to be as accurate as we can. Okay, so there's the parent function. So now let's see what these points should be. And again, if you don't have a graphing calculator, you can plug these values of x in. So do like negative 3 minus 2, which is negative 5. Negative 5 squared is 25. But once you get the hang of kind of a couple calculator shortcuts, figuring out these values and finding your tables is going to help you a lot. So if you go to y equals right now, okay, delete what you have in here by hitting clear. So what we're going to do is type in our transformation. So I'm going to type in parentheses, which are right here. Then you're going to type in x, not the letter x, so don't hit alpha. The graphing x is right here next to your alpha key. So x and then minus 2, and then close in your parentheses. And now you have 2 options to get to the squared. If you look right here, that is an automatic, so if you just hit that button, the squared will pop in. Or to type in any exponent, because our exponent's not always going to be a 2, here's your caret key, so hit the caret, and then it'll pop up there. Okay. So then what I'm going to do, and if you want to jot down these notes, is you're going to hit second, and then hit the graph button to get to your table of values. So second, graph, and this table of values pop up. And you can use your arrow key to scroll up and down. So what I'm going to do then, instead of having to do the math on my own, my table is giving me these values, which is kind of nice. So I will start at negative 3. So when x is negative 3, y is 25. When x is negative 2, y is 16. When x is negative 1, y is 9. 0, 4, 1, 1, 2, 0, 3, 1. Maybe I'll go down one more for this one so I have something else to graph. So 4, 4. So now let's see what we get when we graph these. I should have done that in a different color. So when I go to graph the point negative 325, I can't do that. I don't have enough room on my graph. So I'll go to my next one, negative 2, 16. Again, I can't really get to that one either, so I'll keep going down. So negative 1, 9 is the first point that I can plot. Then 0, 4 would be my next one. Then 1, 1 would be my next one. 2, 0, 3, 1, 4, 4. And then if we think about what I would know about parabolas, it looks like everything's even. So even without filling in the table, if I wanted to join this point, I would have to go one more over and then up to 9. So if we think about what we did in terms of changing the look, okay, I see, all right, the vertex is in the same area. It didn't go up or down at all. It's just over a little bit. But it looks like the width is the same and the direction is the same. So it's not going down, it's opening up. So what we did, this is again another translation. Because a translation is when you just move something. And we went 2 units to the right. We took this parabola and shifted it 2 units to the right. So if we think about the difference between that one and the linear one, here, where did that go? Up. Or even this one up here, I was adding 1 and it was on the outside. It was outside of that absolute value. Here, I'm subtracting 2 on the inside of that function. So I didn't move up and down. This time I moved left and right. Okay. So let's take a look at one more, and then we'll kind of summarize everything here. So let's graph g of x equals the absolute value of x and its parent function. We'll start with the same 5. We'll add or subtract values as needed. This column should be easy to fill in without a calculator or anything because it's just our parent function. So negative 2 is 2 units from 0. Negative 1 is 1 unit from 0. 0 is 0 units from 0. 1 and 2. All right, so when I plot those points, they're going to look like that. This is absolute value. So it's going to have that V shape. So now we don't want to curve it. We want it to have that point at the bottom. All right, now let's think about what changed between the equation of my parent function and the equation of my transformation, and think about other things that we have done so far that have been similar. Okay, well, if this is my transformation, I don't see anything being added or subtracted from it anywhere. So I would anticipate there not being a shift of some sort. I do see this is being multiplied by a negative. Well, when we did that here, when we multiplied this by a negative, that flipped our line. We were going positive in our parent function, now we're going negative. So let's see what happens when I do that. Okay, well, we can do the same thing by putting it in our table. To get to the absolute value, so type in the negative first. On the graphing calculators, be careful. Negative is not minus. There's a negative key down here next to your decimal. So hit negative. And then to type in the absolute value, you want to go to Math. So hit this Math menu right here. Scroll to the right to get to your Number menu. And then option 1 is absolute value. Okay, now the TI-83s don't have the bars. It'll say like the ABS and then parentheses. It's the same thing. Your software is just not quite as updated yet. Okay. So then I'm going to go to my table again. So the table option is above the graph. So second graph, and then we can put these values in our table. So -2, -2, when x is -1, y is -1, 0, 0, that's going to be -1, and that's going to be -2. So when I plot those points, -2, -2 would be down here, -1, -1, 0, 0, 1, -1, 2, -2. So again, I didn't shift it up at all. It has the same kind of point down here, but now it's flipped, and that has to do with this negative. Okay. So let's kind of sum up the transformations that we've looked at. So we looked at examples where we were going up or down. That's called a vertical translation. Okay. So when you see a transformation from your parent function, and it's a vertical translation, again, let's think about where everything was being added. +6 was up 6. +1 on the outside here was up 1. +1 on, or -4 on the outside here was down 4. So when you're looking at a vertical shift, a value, and we'll just call that value K, is being added or subtracted on the outside of your function. And we saw that if K was positive, we were shifting up. And if K was negative, we were going down. The one where we were going horizontally, so this quadratic one right here, we were shifting to the right a little bit. And notice that was happening on the inside of your function. So before we squared it. So if we had x squared minus 2, we would have been shifting down because this is your input, so we didn't change the input. We kept that as x. But here we're making our input x minus 2 and then squaring that. So when I say inside or outside change, that's what I mean. Again, look at what's being squared. If it's just the x is being squared and then you're subtracting something, that's outside of this. But now what's being squared is this whole quantity. So that would be considered on the inside. So a horizontal translation is when a value, and we'll call this one something different. We'll just call that h, is being added or subtracted on the inside. And we'll talk a little bit more next class, but if most of you guys saw this, I would guess that because you saw the minus, you would probably say, oh, that's going to go to the left because it's minus. But it actually went to the right. So the shift is kind of in the opposite direction of how And we'll talk more about that next class when I actually am seeing you guys. And then the last was the reflection across the x-axis. Okay, that happened when we were multiplying by a negative. We are mainly going to be looking at multiplying by a negative on the outside. So that's when you reflect across the y-axis. When you're multiplying on the inside, you would be shifting across the y-axis. But so if you, again, don't see it, if you see it outside parentheses or if there are no parentheses, then that's an outside change. We're going to be looking mostly at those. Okay. All right, so you have got an around the room posted as your assignment on Canvas. So if you are listening to this for the e-learning day, that is your assignment.